This is a straightforward example, typical of what you may have found in maths methods. We're asked to calculate the area enclosed by the graphs y equals x minus 1 all cubed and y equals x minus 1. It is represented here graphically. The curve in blue is labelled y equals x minus 1 to the 4. That should be cubed. So it asks us to calculate the exact area enclosed between the curves. Looking at this particular question, we can see that the curves cross once, twice, 3 times. So the first thing we're going to do is we're going to look for their point of intersection. That is, when the two curves equal each other. At a point of intersection, that means the x values are the same and the y values are the same. So in this case, I'm going to say x minus 1 cubed equals x minus 1. I've equated them because their y values are the same. Now we're going to solve for x to find the x values where they cross. Now, there are a number of ways in which you could go ahead and solve this. The easiest way is to take everything onto the left-hand side of the equation. So we have x minus 1 all cubed minus x minus 1 equals 0. The reason I've left them so grouped is because you can see that x minus 1 is a factor to both terms. So we're going to take out x minus 1 as a common factor, giving us x minus 1, and then that leaves us from the first bracket, x minus 1 all squared, minus, we took out x minus 1 from the second bracket, that leaves us with 1 equals 0. Our next step we're going to do is expand the second bracket. So we've got x minus 1 times x squared minus 2x plus 1 minus 1 equals 0, giving us x minus 1 times x squared minus 2x equals 0. We can now factorize the second bracket. X is a common factor, so I'm going to write x out the front, and x minus 2 was the other factor equals 0. Solving that, x equals 0, or x is equal to 1, or x is equal to 2. Now we have to find the corresponding y values. When x is equal to 0, y is equal to 0 minus 1, so y is equal to negative 1, has a coordinate that is 0, negative 1. X is equal to 1, that will give me y equals 1 minus 1, which is 0. So as coordinates again, that is 1, 0. The last value, x is equal to 2, y is equal to 2 minus 1, which is 1, giving me the point 2, 1. So we now know over on our graph we have an x value of 0 at the first point of intersection, an x value of 1 at the second point of intersection, and an x value of 2 at the third point of intersection. Our graph is going to be the integral from the first part, the blue graph, which is the cubic, is above the straight line. So I'm going to go from 0 to 1 of x minus 1 cubed minus x minus 1 dx. To that, I have to add the second area. The second area was from 1 to 2, but this time the straight line is on top. So it is x minus 1 minus x minus 1 all cubed dx. From here, we could go ahead and anti-differentiate. There's no need to expand if we don't want to, and I'm not going to. We can use our maths methods rules of anti-differentiation. The first integral would come out to be x minus 1 to the 4 on 4 minus x squared on 2 plus x. Between 0 and 1. Our second integral would be very similar. X squared on 2 minus x to the minus 1 on 4 from 1 to 2. Substituting in our values into the integral, we would get 0 minus a half plus 1 minus 1/4. Plus, looking at the second integral, we would get 2 minus 2 minus 1/4 minus a half minus 1 minus 0. That would all come to equal 1/2 square unit. That is not the only way you could have done that question. Because we have the graph there, it is obvious that the two regions are going to be the same area. They're both 1/4 inside. You could have worked out the area from 0 to 1 of x minus 1 cubed minus x minus 1 dx, and then doubled that. Or you could have done the same thing where we would have had 2 times the integral from 1 to 2 of x minus 1 minus x minus 1 all cubed dx. Now looking at our calculator. To find values for the point of intersection, you can see I use the solve function. Solve x minus 1 all cubed equals x minus 1 for x, and it gave me the values as we have done manually. I have defined fx equals x minus 1 cubed minus x minus 1, because here I'm going to use a trick. I could have worked out two integrals and added them together. But what I've done is I've just defined one of them. Now we know the problem with these questions is that the height becomes negative. So if you look at the integral I worked out the integral of 0 to 2 of, and I did the absolute value of fx dx. What that means is where the x value is positive, it will still give you a positive. Where the difference though is negative, because you are taking the absolute value of a negative, it will give you a positive result. So that is another way you can do it if you're using your calculator and you do not want to break things up into lots of different areas.